This recording will cover Chapter 4, Ratio, Proportion, and Percent. Specifically, we're going to look at Section 4.1, Ratio and Proportion, and our objectives will be to calculate ratios, solve proportions, and solve problems involving proportions. So let's go ahead and look at what is a ratio. A ratio is a comparison of two things. You use a division sign to be able to indicate a ratio a lot of times, and you can express it other ways also. But it's two quantities of the same kind of thing expressed usually in the same units. If they're not in the same units, then you have to do a conversion. But basically, think of a ratio as a comparison of two things. For example, the steepness of a hill can be written as a ratio from its height to its horizontal extent, or how far it is in a line that you would go from point A to point B to the base. You can also look at a gear ratio. A gear ratio looks at the number of teeth on the driven gear and the number of teeth on the other driven gear. And so it's a comparison of the teeth from one gear to another, which is, you'll find that in transmissions and other automotive and industrial references. So, looking at simple equations to solve some of these ratios, it's going to be important that we go back and make sure that we have a good foundation in how to work on algebraic equations. And this is really important because we will be doing this throughout the semester. So if you take a puzzle and somebody says, hey, I'm thinking of a number, and if I multiply my number by 3, then I get 15. What's my number? And a whole lot of you probably can do that in your head. And you say, okay, well, I know that 3 times some number is going to be 15. And I know, that if I put a 5 in there, that I can say that 15 divided by 3 equals 5. And that works out great for this type of problem. But what we really want to do is we want to get in the habit of looking at this type of problem more complex and word problems and really trying to figure them out in a strategic way with some tools that you might already know or that we will learn in this class and hopefully be helpful to you. So here's one. A number multiplied by 40 gives 2,200. Find the number. So I pause there because I want to make sure that you get an opportunity to think about this, and also so that we are practicing what you saw in a previous video, or hopefully you saw there's another video from Module 1 that you can go back and watch. It talks about steps for solving word problems. This is just a piece of it. But just to remind you of that, and if you haven't seen it, please go back and watch it, because we will be doing a lot of word problems. I'm going to pause on word problems because I want you to read the problem, to reread the problem, to write down the information that you know. This is a really, really important step. What are the facts? Draw a picture, and then it goes on to solve the problem and find the solution and check for the correct answer. So what I want you to do is we're going to practice that in the videos, and I'm also going to give you a tool that I introduced last week, and that is the keywords chart. You'll find this in the materials section on Blackboard. So look over on the left. It says materials. And if you go over to classroom materials, and you'll find this chart in there. I'd recommend printing this off and having it next to you. Maybe put it in a folder that you do when you do math, because this is going to be really helpful as we move through word problems throughout the semester. So now let's go back and look at this problem that we were given, and maybe the answer came right to you, and maybe it didn't, but let's see how we can solve this using the keywords that we have and using a technique that I call translating mathematics. So from English into math. And this is a technique that I've used for many years with secondary students and post-secondary students, and it seems to be a really easy way, or at least an easier way, for people to pick word problems apart. So, of course, the first thing that we would have done is read the problem, which we did, and then go back and reread the problem. And if you want to reread it a couple more times, then you can pause and then come back, and then we'll start to look at it. So, when we see this, we see a number problem multiplied by 40 gives 2200. So, what are the facts that we have? Well, we know that we have a number, or that they're looking for a number, and that we have the numbers 40, and we have the numbers 2200. Okay, so that's what we're given. We don't know what a number is, so we'll just call that x. Seems like a variable that is used quite a bit. So now let's use our keywords to figure out how to translate this English sentence, a sentence written in English with some numbers, into mathematics. And so going back and looking at the sentence, it says a number, and so we'll substitute that as x, multiplied by 40. And so if we look in here, there's right there, it says multiplied by, so down here. And so we'll just use a dot for multiplied by since we have an x already. Multiplied by 40, that's a good solid number, we know what to do with that. 40 gives, so if we look on our chart here, gives is right down here by equals. Gives means equals 2200. So now that we have that, now we can go ahead and solve this problem. And hopefully everybody is pretty familiar with being able to solve this sort of problem. 40 times x gives us 40x equals 2200. I'm going to cheat throughout this class, just like I hope you do, and go and use a calculator. 2200 divided by 40 equals 55. And the reason why I divided that, make sure everybody knows, is because I want to get this x all by itself. I call it isolate the variable. And so we want to get that x by itself, so I know that if I divide 40 by 40, that's going to give me x, leave me with 1x or x. What I do to one side when I divide that by 40, I have to do to the other. So 2200 divided by 40, bring down the equal sign all the way down, gives me 55. And so that's one number. So the number 55 multiplied by 40 gives me 2200. And I can go and double check that by going 55 times 40 equals 2200. And so, yep, that is absolutely true. So we will be doing this quite a bit. Let's go ahead and go to the next problem, and hopefully there's some for you to practice. So again, I am going to structure this in such a way that I will read the problem, and I'm going to have a long pause at that point in time. I encourage you to pause the video, stop, go back and read the problem, reread the problem until you feel comfortable understanding what that problem says. Maybe even try to look and see what are the facts in it, and if you want to even, how would you solve it? And when you get to a point to where you're like, okay, I'm ready to go on, then go back and start the video again, and we'll solve it together. The reason I really encourage you to do this is because it gives you an opportunity to practice to fail. And that's really important. Practicing failure is important because once we fail on a part of it, we know where we need to work. And we know in our minds, as I go over the rest of the problem with you, you go, oh, aha, I knew that. Okay, great. And I'll learn from that. So again, I'll read the problem, pause, you stop it, come back and restart the video again. So this problem says, find the gear ratio of a system shown if A is the driven gear and B is the driving gear, and whereas A has 64 teeth and B has 16 teeth. So it's looking for the gear ratio. Okay, I'm back from my pause. If you still haven't paused it and you want to, here's an opportunity. Okay, so the ratio of the number of teeth on the driven gear and the number of teeth of the driving gear, we're going to look at that. We're going to set it up. So here is, when it talks about, we're going to pull out the facts. So A is the driven gear. So here's A right here. And this is B. This is the driving gear. And so it's asking for a gear ratio. So we know a ratio is a comparison of two similar things that are being divided. And so we can say that is our ratio A to B. Now it's going to be simple substitution. And we can say gear A has 64 teeth. We'll say gear A has 64 teeth. And gear B has 16 teeth. Okay. So now that we know the ratio of the number of teeth on the driven gear and the driving gear, and we've got it set up as a ratio, we can go ahead and we can reduce this. When I look at this, I say, okay, let's see. 64 and 16, I know that 4 goes into 64 and 4 goes into 16. And I can say, okay, 4 goes into 64. (16 times), and 16 divided by 4, the one I won't even use a calculator for, 4 times, and then I can say, okay, well, let's see. I know 16 can still be divided by 4 times, and 4 divided by 4 one time. So 4 over 1, that's a whole number. Or I can say this is a gear ratio of 4 to 1. And see how it actually says that it is, in technical work, it's actually described as 4 to 1. So let's look at another problem. We're going to find the ratio of diameter of a pulley A and the diameter of pulley B in this drawing right here. So go ahead and pause, and you can read the problem, and maybe you try to solve it if you want. Okay, we're back. And so looking at this, again, we know that it is a ratio, and notice it says it wants the ratio of A to B. So we want to make sure that we say this is A first, and this is B. And then we look at this, and we say, okay, A is down here, and so A is 21 inches, and B is here, and B is 9 inches. Yeah, okay, well, let's see. I know that both of these can be divided by 3. And so 21 divided by 3 is 7 inches. 9 inches divided by 3 is 3 inches. That's as far as it goes. And so being able to look at that, then we will have our ratio of 7 to 3. So ratio of 7, or 7 to 3, or 7. Notice this is another way to be able to write it as well. 7:3. So, or you can keep it in 7:3. One of the things that's really important here is that notice that the units, this time we're in inches, that they aren't in the final answer. And remember, a ratio is a fraction, and it can be a decimal number, or an integer comparison, but it has no units. So make sure that when you're providing, when you're doing your homework, you don't have any units on there after you get done with the ratio. So we're going to go ahead and look at this last one. The pitch of a roof is the ratio of rise to run, where the run is half the span. And we're going to look at a roof. The roof that they talk about is 7, the rise is 7 feet, and the span is 48 feet. So I'm going to take a pause here. Okay, we're back. So let's go ahead and look at the problem here. Now that you've read it and hopefully reread it, looked at some of the facts, I really want to point out in this problem, and this is going to be true in some of the problems in the future as well, they're going to introduce terms that you might not know what it is, but you're going to need to pull those out of the problem. So they're talking about the pitch of a roof. So the pitch of a roof, well, what is that? Well, it is the ratio of rise to run. Okay. All right. Well, then let's see. We know that a ratio is one thing compared to another, and so that means that the pitch equals rise over run. So we're going to say, okay, that's our ratio because it says it's a pitch of rise over run. And it says where the run is half the span. Okay, so half the span of what? Well, when we go on to keep reading, we see that the span is 48 feet. So we're going to need to remember that the run, and I'm going to try this in a different color, see if this works. All right, the run is half the span. So then we say, okay, if we see that the span is 48 feet, we can say 48 feet divided in half is going to be 24 feet. All right, so that's going to be really important. And it also answers this first question, what is the run? Well, the run is 24 feet. And the formula for the roof pitch, as we saw over here, is rise over run. Okay, now that we know that, we've figured that out. So remember, this is, you're watching me go through this. I'm being very intentional on my metacognitive approach, including using the calculator and showing you these step by step, because this is important. You can always go back and look at this again later on if you go, I just didn't quite get that. So it's a nice benefit of having this on video. So here's that roof. I could have drawn this myself on another page, and I probably would have if I didn't know that it was already here. And it really demonstrates, okay, what this is showing. So this is saying that the rise is 7 feet. So notice that's the rise from the top of the walls. So if you're given a problem on homework and you have to figure it out, it's the top of the walls to the top of the roof there. So that's 7 feet. And the span is 48 feet, which we know that the run is 24 feet. And so we say, okay, what is the roof pitch? Well, if we know that it is the pitch, and it's asking for roof pitch, that pitch equals rise over run, then we can substitute our rise of 7 feet for our run of 24 feet, because it's half a span. And we can say that our roof pitch is 7 to 24. Now, roofers are interesting people, and I say that I used to actually roof in Florida, hot tar roof, before I came up to work on a fishing boat in Alaska. And so one of the things that roofers do is they express pitch with a denominator of 12. And so if our denominator over here is 24, the easiest way to get to 12 would be to half that, so divide it by 2, which gives us 12, and that makes the roofers happy. What you do to one side, you have to do to the other. You got to keep it balanced. So 7 divided by 2 is 3.5, and although it's a kind of an ugly number, somebody might say, gosh, well, it's not a whole number. We'll be dealing with a lot of those, but this pitch, technically, if you're talking to a roofer, would be 3.5 to 12. And so that's the pitch of the roof. And that's also the end of this video. So please feel free to go back, watch it as many times as you need to, do the homework, come back and watch it again if it's not making sense. Look at the book. All these problems come from the book, and I don't always approach them the same way as what the book does, so hopefully you're getting it a couple of different ways. That's the intent of providing a distance course where you're not just reading the book. All right, see you in the next episode.